So imagine that you have something like this, where you have an equation. So let's explore what happens when you have an equation that looks like this. Y is equal to a x minus h squared plus k. And you want to compare it to something that looks like this. So what we have to do is we notice that in this second equation that we have here, y is equal to x plus 3 all squared, right? There's only a couple of things that match. There's only this whole section here, which is matched here. So if I want to compare the second equation, which I'm starring here, to the first equation, I have to look at my bracketed portion, and I have to identify where my a value is. So here's what my a value is. So if there's no a value, the a value is 1, right? And I also have to look at my k value here. So if there's no k value on the outside of this problem, we're going to have to make this plus 0. Okay? Now, you know that when we have a is equal to 1, our graph looks like y is equal to x squared. So it looks like a graph that opens up, but it looks like y equals x squared moved either left, right, up, or down. Now, this portion here, the plus 3, if I was looking at the vertex, okay, the vertex consists of 2 parts. I would say, okay, so you would tell me originally that if it was x plus 3 inside my bracket, the x plus 3 means it moves. So this part means it moves left 3, which means our vertex, when I go and put that into my vertex, is going to be negative 3. So remember, inside the brackets, it's opposite world. Now, for this last part here, the outside portion here, that tells us whether the parabola moves up or down, right? So if that is happening, that means this graph moves up. Basically, it doesn't move up. Well, it moves up. It doesn't move up, but it doesn't because it's 0. So this value here in my vertex is 0. So if I was going to go and sketch this graph, what we'll do is we'll basically look at all the information that we have based on our graph. So remember, our graph was y is equal to a x minus h squared plus k. That was normal, but then what we had was our new graph of this thing. Y is equal to x plus 3 squared. And what we did was we compared our original equation. We looked for the a value. It wasn't there, so we said it was 1 in front of this, and then in front of this k value. This really means plus 0. So we looked at that and we found what our new vertex was. Our new vertex was going to be negative 3, 0. Okay, now remember, this portion here inside the bracket is always the opposite of what the x value is in our vertex. And for this green portion here, that is always the same value as what you see on the outside. So now let's graph. Now, its vertex, we said when we were looking at this graph, if we were using the terminology that we used before, this was left 3 units. So remember, the main point that we use on our basic parabola of y is equal to x squared is over 1 and then up 1. So we went over 1, and then up 1, over 1, up 3, over 1, up 5. So I got our basic graph here right away. So let's go and just quickly graph that. So I have that point and I graph it. I have these points and I mirror it on the other side of the y-axis. Now, our new vertex, I'm going to draw in red because it really pops. Our new vertex is going to be 3 to the left. So I'm going to count 3 spots this way and move all the points over. So I'm going to go 1, 2, 3. There's my first point. Now, if I use the same steps that we did before for our vertex, remember our steps on a basic parabola with a value equals 1 are 1, 3, and 5. So we're going to go over 1, up 1, over 1, up 3. And we know from here on, this dashed line here would be our axis of symmetry because the axis of symmetry goes through our parabola. And I just go and sketch my points. So now all I've done is that. So when you go and sketch these things, you don't necessarily have to put them on graph paper, but it does help you later on. All you do is you draw a parabola to the left 3 based on this minus 3 that we have here and the 0 here. Okay? All right. So now let's all go back to that chart that we were working on at the beginning for question number 2 on 3.1. So basically we're going to write our equation up top here. So I'm just going to write y is equal to bracket x plus 3 squared. And what you have to do is you're going to have to make sure that you do some sort of analysis on a separate sheet of paper. So you got to do your analysis. And once you've done your analysis, you can use that to enter the information up here. You look at the a value. It's 1 in this case, and because it's 1, the direction of the opening is up. The vertex we calculated to be -3, 0. The axis of symmetry is x equals -3. Is this a max or a minimum? So the max or minimum value is whatever our y value is in our vertex. So in this case, it's 0. So you'd say this is a minimum because it's opening up and its y value is 0. Is this a stretch or a compression? Because a is 1, this is no stretch or compression, none to deal with. You would say a is equal to 1. Okay, now the values that y takes, because y is greater than or equal to 0, you just go y is greater than or equal to 0. Or you write that in sentences. Now, if you're not sure what this graph would look like, you'd look at your graph and you'd see your graph looks like this, right? With point 0, -3, 0, right? And you'll know that the y values go from 0 up, so y is greater than 0. Greater than or equal to 0. So that's what this part is here. Now, the steps used for the graphs. All the steps for every parabola starts with the following. And the basic steps for any parabola, let's say I have y is equal to x squared. I'm just going to write this in red now. Black. So for the steps y equals x squared, the steps are 1, 3, and 5. Now, let's say I had, for our new equation, y is equal to this. We know that our a value is 1. So all we're going to do is we're going to multiply every one of these values of 1 through 5 by 1. So you're going to get our new values of 1 times 1 is 1, 1 times 3 is 3, 1 times 5 is 5, and then we just write 1, 3, and 5 for the basic drawing of our graph. So now let's just quickly go over, and that's it. We're done.